Hi everyone, this is the admission interview question where quite a number of people don't even know where to start from. That is why I'm here. We're going to break this down bit by bit for better understanding. 3 raised to the power of x plus 2 minus 3 raised to the power of x minus 1 equals 25. And the value of x is going to be what? And don't forget, at the end of the day, whatever the value that we have gotten for x, we're going to plug it back into the position of x and see if at the end of the day this left hand side is just going to be equal to this right hand side. What I have seen quite a number of people doing solving this kind of question is people do apply logarithm to both sides of this equation. Trust me, you don't want to do that because it's going to be a kind of complex things to handle. Of course, nobody's heading to anywhere doing it that way. Actually, this is wrong approach to this kind of question. We are not going to do this. What we're going to do is to deal with the question with the way it is. This is indices kind of question, and we're going to apply index rule here, which says when we have a raised to the power of m, then multiply by another a raised to the power of n, and the result of this is just we pick the first one, which is a raised to the power of n, then we have the power of the second one, n. So as we can see, this format is exactly what we have here. So we're going to need to write the left hand side of that format, and at the same time, when we have a raised to the power of m, but this time around divided by another a raised to the power of n, and this is just as we pick the first one, which is a raised to the power of n, then minus the power of the second one, n. As well as we can see, this format is exactly what we have here. So we're going to need to write the left hand side of that. Now this equation is going to become 3 raised to the power of x. Then this time around it's going to be, because we're writing the left hand side of what we have here, so which is multiplied by, we have multiplication here, the same thing as what we're going to do. Then the power is, don't forget, the same base aa, so we're going to have another 3 here, which is the same base, which is now the power is 2 minus 3 raised to the power of x. The second rule says, or when we have the division in between them, the power is going to be subtracted. We'll have subtraction in terms of power, then the base is going to be divided. The same thing is what we're going to do here. So we have division 3 raised to the power of 1, because we have minus at the power level here, and the equal sign is still having some nice time there, and 25 is still there, haven't gone anywhere. So what we're going to do next, this left hand side can be written as 3 raised to the power of x, then multiply by 9 minus 3 raised to the power of x, then divided by 3, and all this t equals to 25. As we can see from here, we have something in common here, which is 3 raised to the power of x, and is also present here. So why don't we factorize out the common terms? If we do, we have 3 raised to the power of x, we have 9 minus 1 over 3, this is close, then t equals to 25. Dealing with what is inside these parentheses, we're going to say that is the LCM of 3 and 1, because 1 over 3 is fraction, so we're going to make 9 appearing as fraction also by saying divided by 1. So the LCM of 3 and 1 is 3. Therefore, of this one, how are we going to get inside this 3? That's going to be 3. Then we say 3 multiplied by this 9, and this is going to be 27. We have this here, then minus how many of these 3 are we going to get inside this 3? Of course, it's 1. What am I going to do with that 1? I'm saying 1 times this. If I do that carefully, 1 times 1 is going to give me 1. So at the end of the day, inside this parentheses, I have 26 over 3. That is 27 minus 1 is going to give me 26, and I have 26 over 3. And that is what I'm going to write. So 3 raised to the power of x, this as usual now equals to 25. If I write this for clarity, I have 3 raised to the power of x, then into bracket 26 over 3, then equals to 25. Actually, what I'm looking for is x, and my x is standing at one side here, I don't need 26 over 3 for whatsoever at this side, so I'm going to cancel that. What am I going to use to cancel that? That's going to be the inverse of the same thing. That is, inverse of 26 over 3 is just 3 over 26. That is the inverse. If I multiply by that, I'm going to get 1, so I've been able to eliminate that. So I'm going to do the same thing to 25 here, because in mathematics, whatever I do to one side, I have to do it to the other side. So I have 3 over 26 as it is. 3 goes here, or 26 goes here, cancel. Then at the end of the day, what do I have here at this right hand side? This is fraction. 3 over 26 is fraction, so I make my 25 to appear as fraction also by saying 25 over 1. So 25 multiplied by 3, that's going to be 75, and 1 times 26 is still going to be 26. But at this my left hand side, don't forget, the only thing I have here is just 3 raised to the power of x. Now it is time for me to apply logarithm to both sides of the equation. I have log 3x, that is 3 raised to the power of x, equals to logarithm of 75 over 26. And according to the rule of logarithm, this x is gonna come here to this side. According to this rule, the log of a raised to the power of m definitely is going to result into m log of a. That's exactly what's going to happen here. Therefore, I have x to the log of 3 now equal to log of 75 over 26. There is a certain rule I'm going to apply to this right hand side, which says if I have log of m over n, this is going to be equal to log of m minus log of n. If I apply this rule to this left hand side, I'm going to have x log of 3 now is equal to log of 75 minus log of 26. Therefore, I'm going to divide both sides by log of 3. This side divided by log of 3, so I can have what I'm looking for at the left hand side and any other thing at the right hand side. So I need to cancel this log 3 by dividing both sides by log of 3, and which I'm going to do here. So I have log 3 here. By this log 3 cancel this log 3. I have log x equal to log 75 minus log 26, the whole stuff over log of 3. The next thing I'm going to do now is to split this log 3 under log 75 and log 26. That is what I'm going to say. For example, if I have 3 over 5 minus 1 over 5, actually this is just the same thing as if I have, or the SN is just the same thing, which is 5, and I have 3 here. That is, 3 goes in 5, that's going to be 1. So multiplied by 3, I have this, then minus 1 here. So what am I saying? If it is written this way, it's just the same thing as it is written this way. One can see that this is split into 2 here, and the same thing is what I'm talking about here. Now I have x equal to log of 75 here over log 3 here minus the same sign that is there, then log 26 here over log 3. In order to break this further, I need to break down this 75 into its multiple factor. Actually, this is going to help. 75 here dividing by the minimum prime number, that is 3, and in 75 we're going to have 25, then 5 here we're going to have 5, and say 5 goes in 1, then in 5 then we have 1. Actually, I can see that 75 can be broken down into 3 multiplied by 5 raised by the power of 2. Therefore, I'm not going to write 75 here again. This is what I'm going to insert. I have x equals to log of 3 multiplied by 5 raised to the power of 2 over log of 3, then minus log of 26 over log of 3. Actually, there is a rule in logarithm that addresses this. So which says if I have log of n multiplied by n, actually this can be written as log of n then plus log of n. Applying this carefully, I have log 3 plus log 5 raised to the power of 2 over log 3. Then minus log 26 over log 3. Still have some nice time there. Log of 26 over log of 3. Therefore, I'm going to split this exactly the way I split this and as it was explained. We now have x equals to log of 3 over log of 3 plus log of 5 raised to the power of 2 over log of 3, then minus log of 26 over log of 3. At the end of the day, I have 1 here. If I write this, I have x equals to 1 here, then plus log of 5 square over log of 3 minus log of 26 over log of 3. In order to make this simpler, I apply this logarithm rule that says when I have log of n over log of n, this can be written as log of n into this n. Therefore, this is going to become base and this is going to become base. If we apply the rule, we're going to have x equals to 1 plus log of 5 raised to the power of 2 into base 3 minus log of 26 into base 3. To this part of the equation, we're going to use this. Log n base a minus log n base a equals to log n over n. Put this in parentheses, then the same base. If this is applied carefully to this part, then we're going to have now x equals to 1 plus log of 5 raised to the power of 2, that is 5 square, over 36. Put this in parentheses and don't forget the same base, that is base 3. This 5 square is just 25, so I can write that to be x equals to 1 plus, that is log of 25 over 26 into base 3. Actually, this is the final answer and the value for my x. And just before we go, we really need to check if this value of x is actually correct. Going back to the question and insert this and see what is going to happen. That is from the beginning. If we put that value into the position of x here and here, are we really going to get 25? That is to check that out. So let's do this quickly. Wherever we find x, I'm going to replace it with everything here. Then at the end of the day, I'm going to check if this left hand side is actually equal to this right hand side. If it is, it shows that the value of this x is actually correct. Now we need to verify if the answer we've gotten is actually correct or not. Now this is a question. This is the value of x that we've gotten. We are here to verify it. We're going to see if this left hand side is actually equal to this right hand side. What are we going to do is just to insert the value of x that we've gotten into x here, then do a lot of things and see if we're going to get 25 as it is here. Therefore, by inserting 1 plus log 25 over 26 base 3 into the value of x, position of x here, I have 3 raised to the power of 1 plus log 25 over 26 base 3 plus 2. This plus 2 is just the same plus 2 that is here. The whole of this red pen is just the value of x as we have it here exactly is what is there. Instead of writing x here, we just write what the value is. Likewise, the same thing, 3 raised to the power of x minus 1. So we have the value of x written in red pen here, that this minus 1 is still there, minus 1 equals sign is still there, then 25 is still there as 35. As we can see from here, the next thing we're going to do is to add this whole number together. Normally, we can add plus 2, then with 1 together. That's going to be 3. Then at the same time, we have 1 here, then we have minus 1 here. So definitely, this minus 1 is just going to cancel this one here. Therefore, at the end of the day, what are we going to have? This is going to be reduced to 3 raised to the power of 3. Of course, here's the raise. Then we still have log 25 over 26 base 3 there. Then minus, then we still have this 3 raised to the power of log 25 over 26 base 3. Since 1 has gone for 1, minus 1, then plus 1, they both disappear, then equals to 25. Now 3 raised to the power of 3 plus this log is going to need an index rule here. That is, if we have a raised to the power of m plus n, this can also be written as a raised to the power of m, then multiplied by the same base, which is a, then this power, this number, n. Therefore, this format is exactly what we have here. It's just the same thing, so we're going to write the right hand side of this. If we do that carefully, we're going to have 3 raised to the power of 3 multiplied by another base, exactly the way it is here, 3 raised to the power of log 25 over 26 base 3, now minus 3 raised to the power of log 25 over 26 base 3 equals to 25. So you're checking that from this point we can factorize out this 3 raised to the power of log because it's just common on both sides of the minus. If we do exactly, we're gonna have as it is 3 raised to the power of 3, then minus 1 bracket close, still checking if this is just gonna be equal to 25. We're gonna need a certain logarithm also to be applied here. And what does it say? It says that if we have a to the power of log b to base a, this is gonna be equal to b, meaning that this goes, then we have b. Therefore, if we apply the same thing to what we have here, 3 raised to the power of log 25 over 26 into base 3, what are we going to have? Of course, this goes and this disappear. Then we have 25 over 26. At the end of the day, we have 25 over 26 here. That is as it is written. Then brackets open. Then 3 raised to the power of 3. That's going to be 27. Minus is still there, 1 is still there, bracket close. Then is this going to be equal to 25? We are still checking. Now we have 25 over 26. Now into these brackets we gonna have 27 minus 1, that is 26. We have 26 standing there. Then still checking, is this gonna be 25? Okay, then here we make this appear as fraction also, and if we do, this 26 is going to cancel this 26, so we have only 25 here. So if we write that, we can see that this 25 is just the same thing as this 25 here, so which shows that the value that we've gotten, the answer we've gotten for x at the top here is actually correct, meaning that every step that we've taken in solving this is also perfect. That is from the beginning of the question, as it is from here, every step is also beautiful.